Hey you guys, here's a quick video kind of recapping how to find or figure out a common factor of your terms and how to factor difference of squares. So let's take a look first and try to factor out a common factor out of all the terms. Let me find a different writing utensil. Alright. So on the first one, what number can we divide, or what is the biggest term that we can divide 16x to the fourth and 32 by? I see that 16 divides both of them. I cannot take out an x because this guy does not have any x's to contribute, so I'm left with x to the fourth, and then 16 times negative 2 would be negative 32. So you can look at in terms of multiplication, I'm asking myself what times 16 equals negative 32, or you can look at this as negative 32 divided by 16 is negative 2. In any case, if I were to go back and FOIL this out, I should get back my original expression. Now, the next thing I look for is, do I have the difference of two squares? Well, I sure have the difference here. Difference is subtraction, and x to the fourth is x squared times x squared, but 2 is not a perfect square, so it's not the difference of two squares. So I am done with this problem. Anytime there's only two terms left, the only possible pattern that matches it is the difference of two squares. So that's why I don't have the rest of the hierarchy here like I had on my blackboard. Let's see, 50x squared minus 8. Well, 2 divides both of them. Any other larger number? No. So that would leave me with 2 times 25 is 50. I can't take out an x, so x squared minus 4. And in this case, definitely a difference. This is a perfect square since the coefficient's a perfect square and x squared is a perfect square, and 4 is a perfect square. So what you have to do then is you have to think to yourself, what times itself is 25x squared? So 5 times 5 is 25, x times x is x squared. What times itself is 4? Obviously 2. So when you factor difference of squares, you set up two parentheses. One's going to be plus, one's going to be minus. It doesn't matter which one is which. In this case, and you put the first term here, 5x, since 5x times 5x was 25x. And here it's going to be positive 2 times negative 2. And you see that there's no middle term, no linear term, because here when you FOIL it, you'd get negative 10x plus a positive 10x, so that's why those would cancel out. And in this case, what we have left in parentheses, not the difference of two squares, not the difference of two squares, so I know I factored it as far as I can. Next one, I see 7 and 28 share a common factor of 7. This guy has an x, this guy does not have an x. Hold on a second, let me shut my door. Alright, and oh, they both at least have one y, so I can take out a y. So 7, 7, there's no x squared, so I need to put an x squared here, and there's already a y, so I'm good on that term. And 7 times negative 4 is negative 28, y times y squared is y cubed, and there's no x's, so I'm good to go. Now, I have two terms. It's a difference, so it could be the difference of two squares. Let's take a look. This guy is x squared, so that's a perfect square, x times x. 4y squared is a perfect square, since 2y times 2y would be 4y squared. So here, you guys, again, I have the difference of two squares. So I'm going to put two sets of parentheses. One's plus, one's minus. Started out with x. X times x is x squared when we're FOILing. And we know our middle term obviously canceled out, and our last term was positive 2y times negative 2y. And then we look at our parentheses. This is not the difference of two squares. This is not the difference of two squares. Now some of you might be asking, why are you asking that question again since you already asked it? Well, sometimes what happens is the difference of two squares will factor into the difference of two squares. It's kind of crazy, but you always want to keep checking anytime you have two terms left in the parentheses. Last example, a big one. We have three terms, 16, 8, and 4. Common factor of 4 we can take out. This guy has an x, this guy has two x's, this guy has 3, so they can each contribute one x. And y, this guy has a y, this guy doesn't, so there's no point in looking because they all have to be able to contribute the same thing. So 4 times 4 is 16, the x is already there, the y is missing. Move on to this term, 4 times negative 2 is negative 8, x times x is x squared. 4 times 1 is 4, so I could put a 1 or not put anything, that's fine. Well, sure, I'll just put a 1 for the heck of it. X times x squared is x cubed, and there's no y, so I have to put the whole y squared here. Just to double check, is there anything I can take out of these? This is not the difference of two squares. There's 3 terms. It's not a quadratic. And I'm going to save how to factor trinomials when we have 3 terms for another video. So this is just a recap of reminding how to factor out a common factor, and to always do that, in fact, and always look to see if what's left in the parentheses at any point is the difference of 2 perfect squares. Have a great weekend, you guys, and work on that review worksheet so that we can be ready on Wednesday to take a quiz. See you later.